So that brings us to our next speaker, Professor Grazyna Pazikowska-Sapota. I must apologise for my pronunciation. I'm English, I only speak one language. Who is from the Maritime Institute of Gdynia and will be giving a presentation on the effects, I believe, of bio-LNG on the environment. Great. Please welcome.
Hello, everyone. My name is Grazyna Pazikowska-Sapota. I work in Maritime Institute, Gdynia Maritime University, which is a lead partner of liquid energy project. The European Union is committed to full decarbonization as the basis for achieving climate neutrality. However, this requires a complete overhaul of the energy system and its infrastructure by 2050. This goal underpins the European Green Deal, which includes a wide range of plans to intensify climate neutrality. The transition to a climate neutral society will require significant investments in energy efficiency, renewable energy, new low carbon technologies, and grid infrastructure. Both societies and sectors of the economy will play a key role in this action, from energy to industry, transport, housing, services, agriculture and forestry, which will have to reduce greenhouse gas emissions, for example, by ending the use of fossil fuels. Combined with the existing gas infrastructure, renewable and low carbon gases can help to achieve the transition to a net zero greenhouse gas emissions energy system with a lowest social cost. However, it is multifaceted transformation and consists of many interrelated market, technological and legal changes. An accelerated decarbonization pathway, the scale-up of private investments is driven by a more ambitious political and regulatory framework, providing long-term policy certainty. Accompanied by additional support measures, this would enable strong developments in the coming decade by convert industrial facilities of heavy industry into net zero emissions industrial sites based on using hydrogen and biomethane alongside renewable electricity. Also by starting to decarbonize of heavy road transport with a rapidly growing role for hydrogen fuel cell trucks, as well as electric trucks and trucks running on bio-LNG or bio-CNG. Also by move towards the use of LNG as a fuel, paving the way for bio-LNG and possibly ammonia, and increase of the share of renewable electricity in power generation to 70% by 2030, including 40% from intermittent renewable sources and 20% from dispatchable hydropower plants and bio-based power plants. As stated in The report, Gas Decarbonization Pathways 2020 to 2050, an accelerated decarbonization pathway towards a net zero system by 2050, consists of 6 stages. In which biomethane and hydrogen play an important role. The forecast of changes in energy sources until 2050 in the EU area assumes a decrease in the share of petroleum products, a significant decrease in the share of solid fossil fuels, and an increase in the share of renewable energy sources in the structure of energy mix. The forecasts also predict that LNG use will remain relatively stable over time with a slightly declining trend. However, in view of the current geopolitical situation in Europe and the world, this forecast will have to be modified somewhat, but this does not change the fact that limiting climate change by declining from fossil fuels is necessary. Renewable energy sources seem to be an opportunity, especially the increase in the share of biomass and waste in obtaining energy. In the report Gas for Climate 2021, market state and trends in renewable and low-carbon gases in Europe, are stated key trends in biomethane and hydrogen in Europe. These are confirmed trends and emerging trends developing of supply, infrastructure and demand. For example, the confirmed trend of biomethane demand is increased development of bio-LNG and bio-CNG in road and maritime transport. The emerging trend is replacing natural gas in hard-to-electrify industries such as chemicals, steel and food. While the biogas is used to produce heat or to generate electricity, necessary is to remove sulfur compounds and other pollutants harmful to the operation of the plant without the separation of carbon dioxide. Whereas in the case of gas injection into the gas installation or a use as transport fuel, it is necessary to convert biogas to biomethane to remove also carbon dioxide. The process of generating biogas can be divided into 4 closely related stages: hydrolysis, acid creation, acid generation, and methane generation. I have also presented here short definitions of terms related to biogas in order to bring the discussed issue closer. Biogas, it is gas resulting from anaerobic decomposition of organic compounds contained in biomass. Biomethane, it is methane generated in the process of biogas purification of carbon dioxide and sulfur compounds. And bio-LNG, it is biomethane subjected to a cryogenic liquefaction process. There are several bio-LNG production technologies. Most of them have been known for years because they are technologies identical to those used in the liquefaction of natural gas. Some of them are based mainly on pressure transformations. Some of the gas cooling uses other liquefied gases, such as liquid nitrogen or previously liquid methane. However, all gas liquefaction technologies have a common denominator: high investment costs and high operating costs. In 2021, the number of biomethane plants in Europe increased to 992 upgrading plants in operation. However, the development differs significantly between countries, mainly driven by the national strategies and financial support mechanisms provided. France has seen the largest growth of biomethane plants in recent years. For comparison, in Poland, of the end of 2021, were 128 biogas plants, but no biomethane plant. The fear of odor nuisance is one of the most common causes of conflicts during the implementation of investments related to building new biogas plants and biogas production in Poland. Agricultural biogas plants above 0.5 megawatt have been classified as projects that can potentially have a significant impact on the environment. The construction and operation of an agricultural biogas plant may affect the state of air pollution in the scope of standard substances such as nitrogen dioxide, sulfur dioxide, carbon monoxide, dust, aromatic hydrocarbons, and non-standard other substances. Also, ground and water environment in terms of water abstraction, water pollution with sewage and rainwater, especially nitrogen compounds. Also, acoustic climate through noisy emission from technical devices and means of transport. In order to avoid of and minimize the risks caused by biogas plants, it is necessary, among others, achieving and maintaining proper stability of the fermentation process, proper sealing of devices, especially fermentation chambers, elimination or minimization of the use of corrosive elements in installations, control of the technical condition of the facilities with the possibility of immediate shutdown and termination of all devices. Also, adequate training of the staff in the field of operating activities, health and safety rules, and fire regulations. Application of the air composition monitoring system, especially in the buildings of biogas plants, and installation of control systems alerting about failures, and development of a schedule for performing the required checks and inspections. Potential fire and explosion hazards related to the transport, storage or use of LNG or bio-LNG result mainly from three properties of this substance. In particular, at atmospheric pressure, depending on its composition, LNG has a boiling point of around minus 162 degrees. And at this temperature, LNG vapors are much heavier than air. Also, a small amount of the liquid phase of LNG transforms into a large volume gas cloud. 1 unit but volume of the liquid phase of LNG produces about 600 units by volume of gas. Also, natural gas is a flammable gas, so it forms an explosive mixture with air. In order to catch fire, LNG must first be vaporized, heated and brought to a vapor state, mixed with 5 to 15% air and brought into contact with ignition source. The basic problem of LNG or bio-LNG transport is therefore its very low temperature during transport and risk the spill into the environment. For example, the risk of cracking the hull plating. However, there is no possibility of contamination of the environment, seawater or soil, in the event of LNG leak. Because, how I said, upon contact with air, LNG vaporizes and without an ignition source is thinned in air, so it is much less harmful and dangerous than fuel than, for example, crude oil. Also, modern technologies for the construction of LNG tanks, special procedures and security systems ensure an exceptionally high level of security for regasification terminals. The composition of natural gas or biogas, which determines its physicochemical properties, makes it an excellent engine fuel and does not require major modifications and processing. Compressed natural gas engines emit much smaller amounts of harmful substances into the atmosphere than engines powered by traditional liquid fuels. The emission of harmful substances is so low that CNG buses meet current and future European environmental standards. The use of LNG in engines cause the lack of smoke from the exhaust pipe, causes a noticeable difference in the air around the vehicle. When refueling the car with natural gas or biogas, there is no fuel emission to the atmosphere. Also, the breathing effect of natural gas tanks does not occur when stationary, as is the case with traditional fuel tanks. Also, LNG cannot contaminate the ground and groundwater like spilled liquid fuels. Also, the composition of LNG and the lack of carcinogenic substances extends also the life of the engines. Therefore, it positively contributes to the process of utilization and recycling of waste. Summarizing the issues raised, combined with the existing gas infrastructure, renewable and low carbon gases can help to achieve the transition to a net zero greenhouse gas emissions energy system with a lowest social cost. It is a multifaceted transformation and consists of many interrelated market, technological, and legal changes. Renewable energy sources seem to be an opportunity, especially the increase in the share of biomass and waste in obtaining energy. Agricultural biogas plants above 0.5 megawatt have been classified as projects that can potentially have a significant impact on the environment. In order to avoid and minimize the risk caused by biogas plants, it is necessary to keeping strict control of the operation. Potential fire and explosion hazards related to the transport, storage, or use of LNG are small, thanks to the modern technologies used. And the ecological results of the use of LNG and CNG in public and maritime transport are positive. For example, low emission of harmful substances and no possibility of contamination of the environment in the event of a leak. Thank you very much for attention. Thank you.
Do we have any questions, please? Yeah, Pavel.
Thank you. Grazyna.
Yeah.
Everybody's talking about hydrogen as the cleanest fuel ever. Now you have presented, you've just presented some information about potential hazards, potential risks. We are talking about nuclear power. We are talking about oil, diesel. We have a patchwork of different kinds of fuels. Of course, I understand the difference between bio-LNG and LNG, but still, based on your knowledge and experience, what would you say are the most critical aspects and steps to be undertaken to avoid or to make LNG or bio-LNG, of course LNG is fossil fuel, to make it safer, and why is it better? Is it worse than hydrogen or diesel or let's say gasoline? What would you say, what are pros and cons comparing to others?
It is a question for expert, but I'm not expert in LNG and some other fuels. It is my first experience in this project, but I think that using of other fuels such as LNG, hydrogen, maybe ammonia, are better for environment. It is known that they are better for environment than some petroleum products, crude oil or fossil fuels, because contamination of the environment is much smaller.
What to do to avoid the risks? What to focus on? Not technically, but
The risk. I think that it is some risk will be. It is not zero risk, but it is smaller, much smaller than with other fuels.
we know that methane coming from cracking is not maybe the best solution. On the other hand, we are talking about sources like Qatar, like Nigeria. How to convince people in Poland, for instance, that especially decision makers to start believing and doing more, they're doing something to unlock the production of bio-LNG, biogas as such. What is your opinion?
How I said, we have biogas plants in Poland, but to this time we haven't biomethane plants. But I think it is our future, and I think that regulations in Poland should be changed to this way. I think so. It will be possible.
Thank you. Actually, I have another question. I mean, I don't know if you know this acronym in English. We call it a NIMBY. Does anyone know what a NIMBY is? No? Well, it's... Thank you. Not in my backyard, which means that generally you have to win over people if you want to build some kind of infrastructure near to people's houses, like whether it's a wind turbine or whether it's a processing station for bio. And you mentioned, actually, you said there's a fear of odor nuisance, which is one of the most common causes of conflict. I just was interested to know if you have an opinion about whether people generally would be sceptical about LNG, actually, because you just presented and said there were really minimal risks, actually. It seemed too good to be true, in my opinion, but generally people don't want to hear that news. They want to find problems with it. Yeah. Do you think that part of the challenge will be to convince people through the media or whatever that actually it is as good as it seems, because it seems too good to be true? Would you think that's part of is that a challenge, do you think?
I think so. I hope that it will be.
Yeah. But do you think that people, because sometimes, I don't know if you would agree, but people don't want to be convinced sometimes. They don't want to believe it. So if you said, actually, we have the best thing since sliced bread and it has all these positive things, there are no risks. If you have an accident or if there's a potential fire, it will not happen. My feeling is, from experience, people say, I don't believe that. And I don't want it in my backyard.
I think that we need information process and much wider, and it is only one way to to catch the people and to say that it is, of course, other noises is very, but it is better for us, for environment and also for us.
So I guess it's connected with really positive messaging and putting it out there. Great. Thank you very much indeed. Were there any other questions, by the way, for Professor? No? Okay. Great. Well, thank you very much indeed. We appreciate it. Thank you.
Thank you.